welcome back. Okay, so today we're going to learn, because we've been learning about functions, we've been learning about equations. Today we're going to talk about how we can use equations to solve problems, to make predictions, okay, to answer life's toughest questions, okay. So we're on page 234 in your Think Up book. So follow along. Okay. To monitor his progress while grading his students' term papers, Mr. Hutchinson recorded how long he had been working and the number of papers that remained at different points in time. Then he used his findings to construct a scatter plot and drew a line with the equation y equals negative 2.5x plus 35 to model his data, where x is the amount of time working and y is the number of papers remaining. We can answer all these different kind of questions based on what we know. So how many papers did Mr. Hutchinson have to begin with? Okay, where we know that your y-intercept is your initial value. Okay, so to begin with, what did he start off with? 35. Okay, so he began with 35 papers. Again, when you start off with something, that's a keyword for your y-intercept. For every hour that he works, how many papers does Mr. Hutchinson finish? Okay, so they want to know the rate. So what is the rate? It's beside my x, my slope, negative 2.5. So the slope of the line is negative 2.5. So for every unit increase in x, the value of y decreases by 2.5. Therefore, Mr. Hutchinson finishes 2.5 papers for every hour that he works. 3. How many papers will Mr. Hutchinson have left after working 4 hours? Okay, so to do that, we need to know some information. Okay, we need to know that x is the amount of time working in hours, and y is the number of papers remaining. So he wants to know how many would be left after 4 hours. Okay? So when we talk about hours, we're talking about my x. We're going to use my equation up here to solve that problem. Okay, so we know x equals 4. We're going to plug this in here. Negative 2.5 times 4 is going to give me negative 10 plus 35, and that's going to give me 25. So he will have 25 papers left after working 4 hours. Let's look at the next one. How many hours will it take Mr. Hutchinson to finish all papers? Okay. So remember, y represents the number of papers he has left. So when y is 0, that means he has none left. So they want us to find how many hours. So this time we're trying to find x, and y is going to be 0, because when he's done, he's going to have 0 papers left to grade. So I'm going to plug 0 in for y and solve for x. Okay, move this 35 over. Left with negative 2.5, x equals negative 35, divided by negative 2.5, and I'm going to get x equals 14. So it's going to take him 14 hours to finish grading all papers. Let's look at this next one. A travel agency recorded the amount of money spent promoting a vacation package and the number of packages sold. A scatter plot of the data showed the equation of the line that best represented the relationship as y equals 1.2x plus 16, where x is the promotions in thousands of dollars, and y is the number of packages sold. And this is really important. It says x equals 1 means 1,000. So every number you have is going to be in the thousands. Okay? So how many packages would the agent sell if no additional money was spent on advertisement? So how much would it be without any rate to begin with, without advertisement? What's your initial amount? And that's a keyword for what? Your Y-intercept. What's my Y-intercept looking at here? 16. So my answer is going to be 16 packages. For every $1,000 spent, how many additional packages are sold? Okay, so how many additional packages? Okay, we're talking about your rate for every 1,000. Okay, so remember this is going to be over 1. So it's going to be talking about my slope. When we're talking about rates, we're talking about slope. So it's going to be 1.2 packages. How many total packages will the agent sell if 5,000 is spent on advertisement? Okay, so when we talk about money, okay, we're talking about my X value. So X equals. Now notice up here it says 1 means 1,000. Okay, so 5,000, if I take off the zeros, I'm going to have what? 5. So I'm going to plug 5 into the equation and solve for Y. $1.2 times 5 is going to give me 6 plus 16. Okay, and that's going to give me 22 packages. This last one is how much money would have to be spent to sell a total of 28 packages. So Y is the number of packages sold, so Y equals 28. So again, whatever value you have, you're going to plug it into the equation and solve for the other one. So this time, I'm going to plug 28 in for Y. You need to be careful because they're not always going to tell you to plug in for X. So I'm going to move 16 over. Okay, 28 minus 16 is going to give me 12. Divided by 1.2. 12 divided by 1.2 is going to be 10. Okay, now notice they want to know how much money. And if you look over here, they add 3 zeros. So what do I have to do to this then? Add 3 zeros. So it's going to be $10,000. Okay. I'm going to pause it right here. Okay. So turn the page. So then we're on page 235. So colleges surveyed randomly selected students who took a college entrance exam about the number of hours of television they watched daily and their score on their exam. With their findings, a sociologist made a scatter plot and found that the line with the equation y equals negative 0.75x plus 36 best describes the models the data, where x is the number of hours of television watched and y is the exam score. Which statement is definitely true based on the equation? No student's exam score was 36. Not true. Okay, because that's where it starts off with. One student's exam score was 36. Okay, we can't really tell for sure. For every 3 hours of television watch, a student's exam score is decreased by 4 points. Okay, to do that, we need to convert this to a fraction. Okay, if we convert that to a fraction, that is negative 3/4. Okay. For every 4 hours watch, okay, the student's exam score decreased by 3 points. Yes, so my answer is D. Number 2. On several occasions, Court recorded the number of people already in line when he arrived at a local deli and the amount of time elapsed between when he left for his lunch break and when he returned to his office. Using the data, Court made a scatter plot and found this equation of the line of best fit, where x is the number of people already in line and y is the elapsed time in minutes. If Court's lunch break is 45 minutes, would each of these numbers of people in line result in him returning to work? So he has a limit, which is 45 minutes. Okay? So remember, x is the number of people, okay? And his max is 45. So if these are the minutes, we need to figure out how long it takes for this amount to see if he'll be able to return back and work in enough time. So to do that, we're going to use this equation. Y equals 0.5x plus 34.5. So the first one is 21 people are right in the line, so I'm going to plug 21 in for x. And if I put that into the calculator, I'm going to get 45. So it will take 45 minutes. So would it require him, if he only has 45 minutes and he returns in 45 minutes, is that going to give us enough time to get back to work? Is it going to make him late? No. And he's going to have enough time. Let's try 23 people. Okay, I plug that into the calculator, and how long does it take for 23 people? It's going to be, if I do the math, 46. Remember, his limit is 45. Is that going to make him late? Yes. Okay, let's try 22. Okay, I plug all this in the calculator, and I'm going to get 45.5. Is that going to make him late? Yes, it's going to be close, but it's still going to make him late. Okay, let's try 20 people. Plug that, and I get 44.5. Is that over 45? No. So if there was 20 people, he would not be late. And then lastly, let's try 24. And I'll get, use a calculator, okay, and I would get 46.5. That would be over the time, so he would be late if that many people showed up. Let's go to the next one. Cordell owns an ice cream cart and sells various flavors of ice cream cones. The equation for the line of best fit is this. Which of the statements is true about Cordell's ice cream sales? Okay. When the temperature is 55 Fahrenheit, Cordell sells 55 ice cream cones. Okay. So we have this equation. Okay, X is the temperature. Y is the number of ice cream cones sold. Okay, so to do that, we need to plug this in for X and see if it gives us 55 cones. So I'm going to use this equation. Plug 55 in for X. Okay, and I'm going to get 78. So when the temperature is 55, I sell 78. Is that the same thing as 55? No, it cannot be A. Let's look at B. When the temperature is below 40, Cordell sells a negative number of ice cream cones. Can you sell a negative number of things? No. Cannot be B. C. When the temperature is 65 degrees, Cordell sells more than 150 ice cream cones. So let's plug in 65 in for X and see if it's more than 150. And that's going to give me 136. Is it more than 150? No, it cannot be C. C, when the temperature is 90 degrees, which is X, he sells 281. Well, let's plug it in and see if that's what I get. I'm going to plug in 90. Okay, I do the math and I get 281 cones. So when the temperature is 90, I sell that many cones. Is that what D is saying? Yes, so my answer is D. How many ice cream cones are sold when the temperature is 100 degrees Fahrenheit? Again, this is my X. Okay, we want to know how many cones, we want to know the Y. So we're going to plug 100 in for X and solve. And I get 339 cones. So my answer is C. Okay, so let's go to 236. Okay, the scatter plot displays data gathered on the population growth of Jefferson since 2000. The equation y equals 2.5x plus 5 is used to model the data. What does the 0.05 mean? So 0.5 is right here. Okay, that is my y-intercept. So what do you think that's going to be? Your initial value. So what does 5 represent? It is your initial value. It's what you start off with. Okay, we're talking about your y-intercept. The population of Jefferson was 5,000 after 0 years? The population of Jefferson was 0 after 5 years? Nope. The population of Jefferson was 500 in 2000? Remember, it's in thousands. The population of Jefferson was 5,000 in 2000. Yes. Again, it's in thousands, so 5 would be 5,000, 10 would be 10,000. And it's not 0 years, it's years since 2000. Okay? So if I'm on the year 20, I'm actually talking about the year 2000. And let's get this one. Okay. Let's look at 4. To analyze a printer's ink usage, a technician examined how much ink was remaining in a cartridge after different numbers of pages were printed. He then plotted the points representing the data on a scatter plot and drew a line with the equation y equals negative 0.05 x plus 11 to model the data, where x is the number of pages and y is the number of milliliters of ink remaining in the cartridges. According to the equation, how many total pages would need to be printed for the cartridge to have 5.25 milliliters ink remaining? Okay, so I'm going to use this equation up here. So it wants to know how many total pages, which is x. So we are solving for x. If you have 5.25 millimeters, and we know that is y. Okay, so we're going to solve for x and we'll have our answer. So we're going to move this 11 on this side. We get negative 5.75 equals negative 0.05x divided by negative 0.05x. And I'll get x equals 115 pages. So my answer is C. Now for your homework, you're going to do page 239. And 240. So you're going to do both pages, 239 and 240. If you have any questions, okay, please let me know. Have a good day.